So very good morning to everybody present right now, along with Linara Adilova and Michael Kamp. I would like to invite you all to our workshop and parallel or distributed and federated learning. This is the third edition of this workshop, though we actually used to call it decentralized machine learning at the edge before. We renamed it so that we could broaden basically the scope and also include some novel directions in the field, something like privacy preservation, federated learning, especially for medical domains. So let's start. So as we know, we now have a whole number of connected devices. In fact, there was a projection of about like billions of connected devices by this year. And among the ones we know are all mobile phones, autonomous vehicles, smart sensors, a whole bunch of industrial machines, entertainment devices, and airplanes. But of course, as we speak, we have more and more smart devices coming on, and all of them are generating data at a really huge huge volumes. For example, the autonomous vehicles generates about a gigabit per second. We have mobile phones generating a whole bunch of data every second. So before we used to have learning problems with static data. You collected them, they used to be huge, but then a lot of them were static. But right now we have so much of continuous data coming on and at such high volumes. And so the traditional way of learning from this used to be the centralized machine learning, where we used to collect all the data at the servers and then train the models and learn the models. But of course, with this whole volume of data is just becoming infeasible and has already become infeasible. And some of the issues we have with centralized machine learning is massive data storage requirements, which also then leads to other issues of cooling systems, energy, power consumptions, and all the related issues with that, because you are now having to collect all the data at a centralized location. And of course, the network communication overload. And a big issue these days is also data security and privacy, especially for highly sensitive information, especially in the medical domain. And of course, there's underutilization of resources because you are now not using the actual resources of the data generating devices, which do have good computing capabilities and are going unused. And then there's a single point of failure if you have the model getting built at a centralized location. So the trend in the last few years has been to move towards decentralized machine learning. Specifically, a lot of work has been done in the area of parallel and distributed machine learning, where you try to move the computation or training of these models to the actual devices which are generating this data in order to use the resources that are available there. And then it also provides a training time speed up if in general, especially because when you're training all these different models, it's not just one model. Sometimes you have to train multiple models with different parameters. Then that becomes very expensive if you're doing it in a centralized way. And of course, as we mentioned, privacy preservation is a very important factor, and the federated learning has become quite an accepted model for being able to do this kind of privacy preservation and also ensure security of data. Actually, just a few days ago, Google just announced a multi-million-dollar project to do this, to use data analytics and AI for better understanding COVID-19. And one of the researchers that they are supporting is this very interesting project called FACT, which is out of Arizona State University, where they are trying to use their scalable and privacy-preserving federated learning for contact tracing. So as we know, contact tracing can become very have a lot of sensitive information. Of course, firstly, they are actually doing, they're generating graphs of people's movements and who is in proximity to whom. But beyond that, they're also collecting information about the health of the individual person that can be stored on the mobile devices. And they are also using people's voices to be able to recognize if they have some kind of a respiratory ailment. So all this information they are using also to assess the risk of this person for COVID. And all this information, of course, is very sensitive medical information. And hence it becomes imperative that the security of that data is preserved. And hence they're actually using a federated learning approach in order to be able to ensure this. So there is, especially in these kind of scenarios where things like federated learning are very important and essential. So these are some of the more recent works that in this area that we have seen in the past few years. So just go over the program for for the rest of the day today. We will open with Peter's invited to talk about distributed learning in automated driving, which will be followed by a discussion and a Q&A. And we go on for our first talk of the day, which is knowledge discovery on blockchains, challenges and opportunities for distributed event detection under constraints. We will have a half-an-hour coffee break after that, and then move on to our next invited talk by Professor Daniel Curran, which would again be followed by another discussion.